everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with linear regression modeling, and in the last lecture we have discussed the linear regression modeling with respect to the requirements, the kind of structure or the kind of applications. So, to continue this particular aspect, so we have to proceed for the kind of discussion. Let us start with something called as airline cost data, and that is a transportation engineering problem, where the objective is to predict the cost with respect to couple of variables, but since we are discussing about the simple regression modeling, so we will integrate cost with the one particular variables in the transportation sector, that is the number of passengers. In the transportation engineering, so we have a couple of transportation infrastructures, starting with the roads, railways, airports, ports, etc. And this is this particular problem related to airline industry. And here one of the basic objective is how to reduce the cost, and as a result the basic structure is to find out the determinants of airline cost, and from the theory or the kind of overall understanding, the first factor which can influence the airline cost is the number of passengers. So, obviously our modeling will be to determine or to predict the cost, airline cost with respect to number of passengers in the airline. In fact, this is not the only variable which can determine the airline cost. There are couple of other variables which can equally determine the airline cost, and number of passengers is the prime factor which can influence the airline cost significantly. So, as a result, so the first work is to connect airline cost with the number of passengers, then we can extend these models, and that too we will discuss same models in the context of multiple regression modeling, where we will determine the cost with respect to number of variables including number of passengers. Now, the idea is here whether number of passengers can influence the airline cost. So, we have a data set, and these are the typical data structure, and this is what the number of passengers, and this is what the cost per $1,000, and these are all passengers numbers, and we like to check whether the number of passengers can influence the cost factor, and if it is the case, what is the kind of nature, and that too whether there is a negative relationship or positive relationship, and then we have to check whether the particular relationship is statistically significant or not. And corresponding to this objective and the kind of transportation engineering problem, and we need to apply engineering econometrics tools, that to bivariate regression modeling, or means in other words, it's a simple regression modeling, where cost is declared as a dependent variable and the number of passengers is declared as a independent variables. And since it is a two variable case, and the model will be very simple, so we start with the model like this: y equal to function of x, where since we are discussing again with respect to linear regression modeling, by default the model can be written as a y equal to alpha plus beta x, where y is declared as a airline cost and x is declared as a number of passengers in the airline, and alpha and beta are the parameters, and this is what the mathematical form of the models. From the theory or the kind of an understanding, we like to build a models cost with respect to passengers, and that too there is a linear relationship, and we are hoping the particular variable will have a positive impact on cost. That means technically if a number of passengers are high, cost will be high, or number of passengers will be high, cost can low. So, that means in the first instance we have no clear idea whether increasing the number of passengers will reduce the cost, or increasing the number of passengers will reduce the cost. So, the thing is that we like to integrate with the help of bivariate regression modeling, and then you check the kind of relationship. So, far as the management principle is concerned, increase the numbers, that is with respect to passengers, then the cost can decline. If the passengers numbers are low, then cost should be high, because there are lots of fixed cost involvement. As a result, if the number of passengers will be lower one, then by default cost will be high, and the moment passengers will be high, then the cost will decline considerably. So, means theoretically we have this kind of knowledge, but so far as mathematics is concerned or modeling is concerned, we like to state that there is a negative relationship, or we can start with there is a positive relationship. On the basis of the data, we can check whether the particular relationship is negative or positive, and that too whether it is theoretically supporting or there is something wrong, because there is a high chance that the relationship will be negative. So, by default the indication is that increasing the number of passengers reduce the cost and vice versa, but in reality this may not actually the case, because we are missing some of the other variables to determine the cost. So, the nature may be coming positive, probably due to not involvement of these particular other important variables. So, obviously we will check and find out the kind of solution. So, the first hand of this particular process is to build a mathematical models which can establish the relationship between airline cost and number of passengers. As a result, we have already identified a particular model, linear model. Not necessarily that they are always linear in nature, but there may be some kind of non-linearity, and for that we need to have a data visualization. On the basis of data visualization, we can get to know whether the particular relationship is a linear one or non-linear one. But since we are discussing linear regression modeling, let us start with the assumption that they are linearly related, and accordingly the mathematical model which you have to introduce here is y equal to alpha plus beta x, where alpha is a parameter, beta is a parameter, y is a dependent variable and x is independent variable. And the model itself interprets that even passengers are 0, still there is a airline cost, because cost usually means here we are representing the cost that involves total cost, which includes variable cost and fixed cost. So, variable cost depends upon the number of passengers involved in the process, and fixed cost even that does not depend on the kind of airline passengers. That is how when x becomes 0, y cannot 0. So, y represented by alpha. So, that means what is the particular level of alpha through which the particular problems can be analyzed or the kind of predicted, and for that we will go for detailed discussions. Let us see how is the kind of structure. So, first hand requirement is the data visualization, and if you plot these two number of passenger corresponding to cost. So, this x axis we can put number of passengers and y axis put cost factors, then we will find the plottings are here like this is what the workings, and this is what the boundary, and more or less they are actually, if you will connect, the flow will be coming like this, and somehow it is actually slightly linear, not perfectly non-linear. So, as a result we can actually regress the a particular cost with respect to airline passengers, and that too with the help of linear regression modeling. So, the data visualization is also supportive. So, since data is supportive for the linear regression modeling, we can proceed for the modeling or the kind of estimations. So, let us see how is the kind of process. So, this is how the mathematical kind of structure. Here we have two different model. First one is called as a mathematical model, the second one is called as a econometric model. The first models brings that y equal to beta 0 plus beta 1 x, and second one is y equal to beta 0 plus beta 1 x plus epsilon. And in the first case, particularly for mathematical model, there is a relationship between y and x, and that too with the involvement of two parameters beta 0 and beta 1, and that too without the involvement of error terms. That is what the particular case here. But in the context of econometric model, so in addition to y equal to beta 0 plus beta 1 x, we have a epsilon, and for that we need to clarify, and in the econometric model and in the statistical model, we usually introduce the error terms with the justification that nothing is exact. So, that means technically x is not the only variable which can influence y, and that is the first and kind of clarifications. So, obviously, the question is what is the need of introducing the error term, because the thing is that in the process of statistical investigation or econometric investigation, we assume that there is something wrong or something lacking, and if you say that perfectly okay, and there is nothing lacking or something wrong, then there is no rule of statistic and econometrics. In fact, if it is perfect, still we can use statistic and econometrics. In that case, we will find the error will be completely 0. So, whether there is a kind of error or not error. So, on the process of modeling, you can get the clue, and accordingly we can go for establishing this particular relationships, and then go ahead with the kind of a requirement. So, we have two different models here, mathematical models which is error, without the involvement of error, and econometric model which is actually involvement of error term. And I like to point out why there is a need of error terms every time when we do the econometric analysis, and that to regression modeling. So, in the first end, as a researcher or as a kind of analyst, so you cannot sure whether the particular setup all the variables are clearly identified, and you have no idea how these variables are actually related, whether there is a multivariate kind of relationships or simple kind of relationship, and whether there is only one variable which can influence the dependent variables, whether there are multiple variables which are involved in the process of regressing dependent variable. The thing is that at a particular point of time, you are not sure how many variables can influence the cost here, airline cost here. Even if you theoretically you identify for 5 variables, still you will not sure that these are the only variable which can influence the dependent variable. So, as a result, there is something wrong. So, that particular wrong can be captured through the error term. This is the first justification which we can bring here to justify that there is involvement of error term in the econometric modeling. And likewise, there are couple of regions you can point out for that to justify the involvement of error term in any kind of econometric modeling and or regression modeling. So, for instance, there are certain factors which cannot be identified, which and there are certain factors which can be identified and cannot be quantified, cannot be captured, and sometimes there are human errors, sometimes there is a kind of external factors which is not in your control. So, likewise there are couple of factors or couple of indications through which we are in a position to justify that there is a need of involving error term in the process of modeling, that to establishing the relationship between dependent variable and independent variable. The moment we are establishing the relationship between dependent variable and independent variable, that to y with respect to x, where y is the only variable and x may be one, x may be many. So, in both the cases, so there is a need of involvement of error terms. In fact, when we will go for multivariate where there are more number of y, more number of x, the situation may be more drastic and more complex, but in the meantime, for the bivariate structures, when you are integrating y with only x, then obviously there is a serious doubt that how do you decide that this is the only factor which can influence y. Again, when we go for multiple regression, let us say instead of single x, you can have a 3 independent variables or 4 independent variables, but still there is again doubt, or there is not sure that these are the only variable which can influence the dependent variable. So, that means in totals we are in a position to justify that there is the involvement of error term in the process of econometric modeling, that to establishing the relationship between y and x, that to the relationship between dependent variable and independent variable. So, the difference between the two model, mathematical model and econometric model is that in the mathematical model there is no involvement of error terms, and in the case of econometric modeling there is involvement of error term. And the process of econometric modeling is to check what is the level of error terms, whether it is a 0 or not 0. If not 0, in what extent it will affect the systems or the kind of modeling. So, the whole idea of econometrics analysis or whole process of econometrics analysis to how to minimize the error terms, and so that the model will be very perfect and the accuracy will be come into the picture. So, the whole job of the econometricians and the engineering econometrics process is to minimize the error term with respect to these parameters or the kind of variables involved in the process. So, here on the basis of this econometric modeling, so we have two parameters beta 0, beta 1, and then epsilon is the error terms. On the basis of that, we will do the processing, and in the first hand processing, the compared to econometric modeling. So, the thing is that since the model is not perfect, there is some kind of volatile is there. So, we need to find out within the particular volatility what should be the perfect line or predicted line, or sometimes called as a best fitted line or line of the best fit. So, for that we need a estimated equations, and that means technically the job is like this. So, this is how the kind of data visualization. So, in the first end, the if you join all these points, so the point will be coming like this. Okay, so this is how you join all these points, and then you will get actually this is how the curve. So, that means there is a slight volatility, and as a result the prediction accuracy or forecasting accuracy is not so significant. So, what is the role of regression modeling is that to find out a line which can be very easy for a researcher or analyst to predict the dependent variable with respect to independent variable, and for that hypothetically we can draw a line like this. So, this is what it is called as predicted lines, we call as a y estimated, and this particular the volatile kind of line is called as a actual y. So, technically the actual y is equal to estimated y plus error terms. So, as a result error term is equal to y minus y predicted. So, that means the actual behavior y is not in a line. So, there is a ups and downs, but the predicted line will be in a line, that is what is called as a line of the best fit. Since it is a linear one, so obviously the particular line will be like a straight line, and the line should be in between all these points, that because it justifies the average relationship between dependent variable and independent variable. So, theoretically we are drawing the line like this, but actually it can be derived mathematically. So, that means technically once you know the parameters value, so we can get to know what is the what are these points corresponding to this particular estimated variable, and then you can draw the means you generate the points and draw the line. So, you will find the particular line will be straight line, and that will be within the in between all these points. So, technically y hat equal to, that is estimated equation, which is nothing but called as alpha plus beta x. So, y hat equal to alpha hat and beta hat. So, when we write actually first hand equation y equal to alpha plus beta x plus epsilons, that is the error term. So, this is econometric modeling in the first hand, but in the process of estimations we will get a estimated line which is called as a y cap, and that too which is equal to alpha cap plus beta cap into x. Alpha cap is the estimated value of alpha and beta cap is the estimated value of beta. So, now the moment when we transfer y equal to alpha plus beta x plus epsilon to y hat equal to alpha hat plus beta hat x, so error will be actually minimized. So, that means technically we need to minimize the error term. The way we will minimize the error term, by default we can get the values of alpha cap and beta caps. That means technically your error equation equal to y equal to e equal to y minus y hat, and that is y cap, that y equal to alpha cap minus beta cap x. Okay. So, that means we need to minimize this e, and that is how we have to optimize the particular process. Means technically we if you go for optimization, then the single e cannot be optimized. So, what we will do, we will go for squaring the particular error term, that is called as a error mean square, and then we will minimize the error mean depending upon the particular situation or the kind of equation. So, that means technically, so what will you do mathematically? So, we can square both the sides. So, then it becomes e square equal to y minus alpha hat minus beta hat x squares, and then we take summation both the sides, and now we have to optimize or minimize the error sum squares with respect to alpha hat and beta hat, because these are the only two parameters which you need to know, because previously they are unknown, and the process of this minimization will bring you the alpha hat value and beta hat value. That means initially we have the equation where alpha and beta are unknown. Now, with the process of estimation, we can get to know these values of alpha and beta. As a result, now alpha and beta are known to you. So, the moment you know alpha hat and beta hat, then it is easy to predict the particular y corresponding to the involvement of x, because in the process of data, so you will find, so this is what the actually x data. So, that means technically against 61 passengers the cost factor is 4.28, against 63 4.08. Likewise, the last component will be when there is a 97 passengers, the cost factor is 5.56. So, now likewise there is a kind of increased number of passengers, 61 to 63, 67, 69, 70, 74, then 91, 95, 97. So, likewise let us say if it is 99, then what should be the cost factor. So, that is how the simple understanding of this particular problem. So, now once you know a particular equation, then it is very easy to predict the kind of phenomenon. For instance, the line is equal to y equal to alpha head plus beta head x. So, now for the next cost factors depending upon the number of passengers. So, here it is last number is 97. Now, if we assume that if x equal to say 97 or x equal to 100, then what should be the y value? Okay, what should be the y value? So, now by the process of regression modeling, we will get a equation like this, where alpha head and beta head are known to you, and for that we are minimizing the error sum squares and then getting the values of alpha head and beta heads. So, now since alpha head and beta heads are known, maybe equal alpha head equal to 2 and beta head equal to 3, and that means technically the equation will be y head equal to 2 plus 3 x. So, now putting x equal to 97, so you can get y head value, and again putting x equal to 100, you can get the y head value. So, that means it is very easy to predict when the values of alpha and beta are known to you. So, now our first task is to know how these values are means these values can be obtained. Okay, so, that means technically we like to know the procedure through which alpha value and beta value can be calculated. The moment you calculate the alpha value and beta value, then you can easily predict the particular cost subject to number of passengers, right. Whether it is increasing, decreasing, there is no such issue, but ultimately you will get a kind of path through which you can predict the particular cost depending upon the number of passengers involvement. So, now to do that, so we can proceed for the particular processing, and this is what the modeling, and then let us assume that this is what the estimated equations. So, we assume that the estimated equations which we have already obtained is called as a y cap equal to alpha head plus beta head x, which I have already highlighted in the previous slide. So, now here b 0 is nothing but called as a alpha head, and beta b 1 is nothing but called as beta heads. So, that means technically beta 0 b 0 is a kind of intercept line of the intercept, and b 1 is the slope, and y head is the predicted value of y. And then now we like to know how b 0 and b 1 to be calculated. Of course, b 0 is nothing but alpha head, that is the estimated value of alpha, and b 1 equal to estimated value of beta, that is beta cap. So, what is the typical structure or the kind of formula through which you can calculate the b 0 and b 1, that to alpha head and beta head. So, for that the process is to minimize the error sum squares, and the moment you will minimize the error sum square, you can easily get the values of these parameters. So, ultimately the process we like to follow is like this. Usually the process will be process will be followed by some of the tools or techniques, that is called as ordinary least squares, like generalized least square, weighted least squares, maximum likelihood estimator. So, these are the different techniques are available to help the process that to minimize the error sum squares and to get the values of these parameters. But usually in the regression modeling or econometric modeling, the starting procedure to have the estimated values of this parameter by deploying the technique called as a OLS, that is called as a ordinary least square methods. The process of ordinary least square is to minimize the error sum. So, that means here we use a technique called as a ordinary least squares. So, here the process of OLS is to minimize the error sum square, summation is square, which is nothing but summation y minus y cap whole squares, and that too we have to minimize with respect to the unknown parameters, that is alpha and beta, and the moment we will minimize, then the process will give you two different equations altogether. So, the equation will be like this: summation y equal to summation y equal to n alpha plus beta summation x, and summation x y equal to alpha summation x plus beta summation x square. So, now these are the two equations which we will get from the process of OLS. That is through the minimizing the error sum square, and since we are minimizing with respect to alpha and beta, so there are two different procedures. First is the necessary condition and the sufficient condition. The necessary condition is the differentiate the particular equation with respect to alpha and differentiate the particular equation with respect to beta. The moment we differentiate the particular equation with respect to alpha and then to simplify the process, you will get the first equation, which is nothing but summation y equal to n alpha plus beta summation x. And again, so when you differentiate with respect to beta and then simplify the process, you will get a equation called as a summation x y equal to alpha summation x plus beta summation x square. So, now from the data structures, we have y value and we have x value. Okay. So, now if you go to this modeling, so we need to find out alpha value and beta value, and by the way, in the data set we have y information and x information. So, that too we need summation y. Since it is a y series, we can easily get summation y, and since again x series, you can easily get summation x. Just to add these numbers with respect to y, then you will get summation y, and again you add all the x points, then you will get summation x. And for first equation, the unknown component is summation y, which we can derive from the y series, and summation x, which is derived from the x series, and n is the sample size, number of sample points. And then in the second equations, the requirement is summation x y, and for that y and x, we can create a variable here x y, just to multiply y with respect to x, then we will get a series here, and again take this sum, we will get summation x y. Then summation x is already here, and we need again summation x square. Since x is a series here, so we can create another series here x square by squaring x items. Then you generate the points, and finally you will get summation x square here. So, ultimately with the data set, you can easily get all these items, and then put these items in the particular in these two particular equation, and simplify, you will get the values of alpha and beta. And once you get the alpha values in this process and beta values in this process, so alpha can be treated as a beta 0 and beta will be treated as a b1. So, that means previous alpha and beta are unknown. Now, these estimated beta alpha and beta are known to you, and which are named as b0 and b1, and that these are all derived from the particular samples. So, that is the process through which you can get the estimated equations or estimated line, and that too the values of the parameters. And now with the help of these two equations, if you will simplify, then you will get a b0 like this and b1 like this. For instance, the equation structure will be like this: summation y equal to n alpha plus beta summation x, and summation x y equal to alpha summation x plus beta summation x square. So, now you can divide n both the sides, then if you simplify, then this will give you to this equation, and as a result it will give you solution to alpha component. And now for beta component, that is b1, so you have to simplify the entire equation, and that will give you to the value like this. So, it is a beta estimate equal to n summation x y minus sum x into sum y divided by n summation x squares minus sum x whole square. So, this is actually the kind of beta coefficients. The process is to first find out beta coefficients by this particular formula. It is something called as covariance of x y by variance of x. So, that means beta coefficient for a bivariate model is nothing but covariance of x and y divided by variance of x, and then you calculate first beta coefficients, and after getting the beta coefficient you can put here in the first equation, and you will get the alpha coefficient. So, that means this is a mathematical procedure through which you can get alpha coefficient and beta coefficient to predict the dependent variable, that is y, with respect to independent variable x. Of course, software will help you to get these values very easily, but this is what the theoretical understanding or technical understanding how to get or how to process the particular modeling, so that the alpha values can be obtained and beta values can be obtained in the process of Wallace estimation, and that to determining the cost or predicting the cost with respect to airline passengers. So, these are the process through which you can actually obtain the values of the unknown parameters, and once you get the values of the unknown parameters you can easily predict the kind of y, and this is how simple procedure. What I have already mentioned, beta coefficient is nothing but covariance of x y by variance of x, and this is nothing but actually y bar minus beta hat x bar. Since beta hat is obtained here, so you can just simplify and get the answers, and for that this is what the procedures. So, we have x information and we have y information. The way which I have already highlighted, you can easily get summation x y, because our standard equation equal to summation y equal to n alpha plus beta summation x, and summation x y equal to alpha summation x plus beta summation x square. So, now from x and y, this is our original data structure. Then with the process you can get x square series, you can get x y, and that too as per the requirement of these two equation, and which will derive from the process of Wallace, that to minimizing the error sum square, and to obtain the values of the alpha and beta. And now creating x square you can get summation x square, creating x y you can get summation x y, and with the availability of x you can get easily summation x, and with the availability of y you can easily get summation y. Now put all these value in these two equation and then simplify, you will get the values of these parameters. In the next slide it will give you the indication here. So, now after putting all these things, so you will get beta 1 first, that is the covariance of x y to covariance of x y by variance of x. So, that is what the particular beta coefficient which is called as b 1, and this is alpha coefficient, which estimated alpha coefficient which is called as b 0, which is nothing but y bar minus beta hat x bar, that is b 1 x bar, and as a result you will get this value. So, this is technically called as a beta coefficient, and this is technically called as alpha coefficient. So, obviously our estimated equation is y hat equal to alpha hat plus beta hat x. So, now alpha hat is coming here 1.57 and plus beta coefficient is coming 0.0407 and that to x. So, this is how the estimated equation, and this is estimated equation or estimated line, and for that you can now predict the y with respect to x, because alpha is now known and beta is now known. Of course, they are constant, whatever values of x, and that to predict the y. So, that means x will change one point to another point, but alpha intercept will be constant and beta intercept will be constant for this particular sample, because it is now the average values of this particular series that represent the parameter, and then you can predict x with y. So, this is very easy to process, and then it will help you a lot to predict some of the engineering problems, like this transportation cost or something like that. So, so once your understanding is clear and the process you will be acquainted, then you can actually easily work out, and then it will help you a lot to examine the kind of things, and to decide what should be the predicted cost subject to the passengers increase or passengers decrease. And after getting the predicted lines, you can do the prediction in these problems, that to airline cost subject to airline passengers. But before you go for prediction about the airline cost with respect to airline passenger, the model need to be checked perfectly. This is the estimated models. Now you can easily go ahead with the prediction, but there may be some of the requirements, there are some of the errors which you need to check and clarify before you go for the predictions. So, in the next class we will discuss all these obstacles. Before you start the prediction, you should check all these obstacles, and give the green signal that yes, this model is perfect to predict, and you can go ahead with the prediction as per the particular engineering problems requirement. With this we will stop here. Thank you very much.